Okay, so this is going to be an interesting chapter, interesting section we're going to talk about because now what we're going to do is we are going to take the unit circle off of the circle and we're going to move it onto the Cartesian plane. So we're going to unravel the circle and we're going to put it on the XY plane, as you can see down here. We're going to do it twice. And the idea is that we really want to understand where the graphs of sine and cosine come from in regards to the unit circle. So some quick things to keep in mind here is when we're dealing with, and we're going to start off by graphing the sine function. We'll graph the sine function. We'll call this y is equal to sine of x. We're going to graph the sine function over here, and then we'll do another space over here for the cosine function. Now remember, when we're graphing the sine function, that means that, or when we're dealing with the sine function on the unit circle, that means we're dealing with the y values of our terminal point. So we're going to graph the sine function. We're going to start off right over here at 0. So if we have 0 radians, we have a y value of 0, which is right here. So let's graph that. At 0 radians, we're at 0. Now at pi over 2 radians, notice we have a y value of 1. So that means at pi over 2, I am going to be up here at 1. Let's graph that point as well. So at pi over 2, I'm at 1. And now if we continue going on the unit circle over here at pi, notice my y value is 0, so I'm going to head back down here at 0. And if we continue going at 3 pi over 2, so I'm starting over here and I'm going all the way down to 3 pi over 2. At 3 pi over 2, I have a y value of -1, which means our next value here is going to be -1. And let's going, so then at 2 pi, if I close the circle, notice I'm back at 0 again. Well, what if I wanted to continue? So if I wanted to continue going around the unit circle, after 2 pi, we're going to add one more half a pi, so it's 2.5 pi's, which is the same thing as saying 5 pi over 2. And again, notice my y value is 1, so I'm going back up here. If I want to go 3 pi's, I'm starting here. I'm going to go 1 pi. We're going to go 2 pi. We're going to go 1 more pi, so here's 3 pi's, and notice I have a y value at 0. If I want to go 3.5 pi's, here's 1 pi, here's 2 pi, here's 3 pi's, and here's half more. So I have a y value at -1. And if I want to go 4 pi's, so I'm going to go 1 pi, 2 pi, 3 pi, 4 pi, then I have a y value at 0. So this is the graph of the sine function. Now notice I could continue doing this. I could go around the unit circle infinitely that many times. And so in that manner, the shape is going to continue to go, and we have a domain of all reals, so we're going to continue going to the right like that. With that same pattern. Now let's see what happens if I start going to the left. So if I hit some negative radian values. Well, negative pi over 2 means I'm starting here and I'm going pi over 2 units, but in a clockwise manner. So I'd be right over here. My y value is -1. Negative pi means I'm going over here. I have a y value at 0. A -3 pi over 2 means I'm going to go -1.5 pi, so here's 1 pi and half more. So I have a y value at 1. And -2 pi, same thing. I'm going to start here. I'm going to go around the unit circle 1 complete time. So here's 2 pi, and I have a y value over here at 0. So this pattern continues not only to the right, but it continues to the left as well. So in regards to our domain, the domain for the sine function are all reals. So we're going to say from -infinity to +infinity, or all reals. Let's talk about some other aspects of sine. For the range, if we take a look here, their y values, the normal sine function is going to go between 1 and -1. So we have a range of those y values between -1 and 1. Some other aspects of sine that we want to talk about, because sine's an interesting function, but it's going to look a little bit like cosine, so you want to make sure that you can tell the difference between the two of those. Notice that sine, I'm going to call sine my exciting roller coaster, because sine starts at 0. It's a roller coaster that built suspense. It goes up to 1, comes back down to 0 again, goes down to -1, and then stops here at 2 pi. Now, if you notice this starting at 0, going up, going to 0, going back down, and coming back up again, this pattern is repeated. We have that same pattern over here. And notice that this pattern is even repeated over here. That up, down, really far down, and then back up to 0 again. And that repeating pattern, this distance of that repeating pattern here from 0 to 2 pi is what we call one period of the function. So a period is where the function begins and where it ends before it starts to repeat itself again. So our sine function has a period of 2 pi. Some other aspects that we want to talk about sine. Notice on that period, that 2 pi period, we have 3 x-intercepts. I have one here at 0, I have one here at pi, and I have one here at 2 pi. So we have 3 x-intercepts. And notice also that we have a maximum or a high point over here at 1, and we have a minimum or a low point here at 3 pi over 2. The important part to remember in regards to this function is we're starting at 0, we're going up, going back down to 0, going down to -1, going to 0 again, and we're repeating that infinitely to the right, and we're repeating that infinitely to the left. And the measure of one of these waves over here is 2 pi, that's called the period. We have a domain of all reals, and we have a range of -1. Now let's compare that with cosine. Let's do cosine. What is the difference between our sine function and our cosine function in respect to what these two functions are going to look like? Now, for the cosine function, remember that cosine is represented by the x value. So now we're going to look at the x values of the unit circle. So if I start here at 0, notice that the x value is 1. So I'm starting at, oh, I don't know why I called that -1. It's because I'm silly. So I'm going to start here at 1. And then the cosine of pi over 2, now I'm going to go to pi over 2, and I have an x value of 0, so now I'm going to go to 0. Let's go to cosine of pi. Pi is over here. Notice I have an x value of -1, so I'm going to go down here to -1. 3 pi over 2, I have an x value of 0, so I'm going to go back up to 0. And 2 pi. Okay, so I went around the unit circle one time, and I end back up at 1. And I hope you see that that pattern is going to continue. So we're going to do this to kind of complete our cycle here. Now, if we go to the left, so that is if we start hitting some negative radians, let's see if that cycle continues there as well. So negative pi over 2 means I'm starting here, and I'm going pi over 2 units to the left, which would take me right here. And I have an x value of 0. So negative pi over 2, I have an x value of 0. At negative pi, if you take a look over, I have an x value at -1. At negative 3 pi over 2, so -1.5 pi, so here's 1 pi, here's 1.5 pi's, but we're going in a clockwise manner. I have an x value at 0. And negative 2 pi, I'm starting here, I'm going around the unit circle 2 pi times, but I'm going in a clockwise manner. I have an x value at 1. So when we kind of connect the dots with our cosine function, here is what we get with the cosine. Oops, I missed that one. Well, I just, oh my, okay. Well, you guys can just, I'll make it really big to make it look like it's connecting over there. So let's talk about different aspects of the cosine function as well. So first of all, I hope you can see that the domain, we can spin around the unit circle forward as many times as we want. We can spin around the unit circle backwards or negative manner as many times as we want. So the domain still is going to be all reals, -infinity to +infinity, or all reals. The range, same thing. We're bouncing back and forth between -1 and +1. So we have the reals at -1 and +1. Excuse me, we have the range at -1 and +1. In regards to our period, well, we can use whatever starting point we want. Let's just take a look over here. If we start here at 0, and if we end at 2 pi, look at the loop that we make. We go high, low, high again. And then notice that's repeated. So here we have high, low, high again. And notice it's also repeated over here. High, low, high again. So the period's the same. We still have a measure of one complete kind of swoop of cosine of going from 0 to 2 pi. So that's telling us that our cosine function has a period of 2 pi. Some other interesting things about the cosine function in regards to its shape. It starts as 1. It's the non-suspenseful roller coaster. So it starts at 1, goes to 0, goes down to -1, goes to 0, and back up to 1 again. And if you notice, we can actually get the cosine function from shifting the sine function and vice versa. We can shift the sine function a little bit and get the cosine function. So the part that you really need to focus on is where we're starting on sine and cosine. Notice at cosine, we start at 1, then we go down to 0, -1, 0, +1. Okay, so cosine starts at 1 while sine starts at 0. That's really important. Now let's talk about some x-intercepts that our cosine function has. Well, we have an x-intercept here. We have an x-intercept here. So we have x-intercepts at pi over 2 and at 3 pi over 2. And from one period for the cosine function as well, we have a maximum value and one minimum, but kind of have 2 maximum values and 1 minimum value. So in regards to our maximum values, we have a maximum value, okay, that's it. We have a maximum value over here at 0, 0, 1. We also have a maximum value over here at 2 pi 1. And we have a minimum value at pi negative 1. So for cosine, we have 2 max and a min and 2 x-intercepts. For sine, we have 3 x-intercepts, 1 max and 1 min. So that's another way to remember the functions when we're talking about them. Note these values, these 1, 2, 3, 4, 5 values, the max, the min, and the 0, I'm going to refer to as critical values. So anytime you hear me talking about critical values, that's the same thing as saying the maxes, the max, the mins, and the x-intercepts. I can't spell. The max, the mins, and the x-intercepts. And all together for sine and cosine, we're going to have 5 of those critical values. Here we have 2 max, 1 min, and 2 x-intercepts. So there's 5 critical values altogether. Here we have 3 x-intercepts, 1 max, and 1 min on sine. So there's our 5 critical values altogether too. And notice that the critical values are all spaced equally apart. They're all spaced pi over 2 apart. That's something to keep in mind. 0, pi over 2. Pi over 2 plus pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. 3 pi plus pi over 2 is 2 pi. That this distance between the max, the mins, and the x-intercepts, the 5 critical values over here, all have equal spacing. It's not so important right now, but it's going to be important in a few minutes. Okay, so to recap, when we are sketching sine, all you have to do is remember this. To recap, when we are sketching cosine, all you have to do is remember this. Once you have those two down, everything else should follow from it. So remember, we have our 5 critical values. Here are the 5 critical values for sine. We have 5 critical values for cosine as well. Those values are all spaced equally apart. Remember that cosine starts at 1, sine starts at 0.